I believe you should be able to see my screen now with my presentation slide, partnering with campuses to advance the nation's science and engineering. All right, so before we start our office hour sessions in separate Zoom rooms, first I wanted to give an overview of distributed high throughput computing services and services relevant to the open science grid that are available for campuses, who for the open science grid are a really important part of what we do and how we advance the nation's science and engineering. So in this presentation, I'll give an overview of the various dHTC services via path, starting with answering the question of what is dHTC, and also the question of what is the open science grid for those of you who might be new. I see a lot of familiar faces in the crowd, but it's good to always provide that overview, and it will be brief. These services also include support for NSF CC Star Awards. I'll mention some of what we do specifically for CC Star proposals and awards, since there's a deadline coming up in early March for the next CC Star round. And I'll also leave you with clear instructions on how to get started and how to start engaging with these services. But the bottom line is you can't go wrong by emailing support@opensciencegrid.org. So the overview of services for campuses is really just sort of a few categories. And in the office hours rooms that we have later, there will be a different room for each of these categories. First, I'll talk about services we offer for you to support your researchers to use distributed high throughput computing and the open science grid today. This includes being able to send your researchers to our OSG Connect access points to submit computing work into the open science grid. We had a whole training yesterday that included how to execute jobs in a dHTC environment like the open science grid using the HT Condor software. And we also do training and otherwise can help build your campus's capabilities with dHTC facilitation. If you want to go beyond pointing your researchers to OSG Connect, where we do that facilitation. You can also look into building local dHTC capacity with the HT Condor software. For example, local computing systems that are oriented toward dHTC, and we'll have a room with some Condor experts ready to talk about those opportunities beyond the overview I give today. You can pursue having a local access point into OSG, meaning an interface like a server with Condor-based job submission available to your researchers that can be configured to submit into the open science grid and to other forms of computing capacity. So there's a room for that. And I'll also talk about sharing local cluster capacity into the open science grid. If you have computing resources at your campus that may be going unused and or you'd really like to contribute to the broader science community. And that one is particularly relevant to CC Star. So if you've got questions about that, there's a room specifically for this topic too. All of these services are free and open, and we offer facilitation for campuses from our research computing facilitators, including myself, to help you navigate them. So today's a great opportunity for you to learn more about these, to ask even very specific, sometimes technical questions about the different services, but we can also just point you in the right direction or have bigger conversations about what might be best for your campus and your researchers. And all of these are brought together now within the NSF-funded Partnership to Advance Throughput Computing. This is a partnership between the Open Science Grid and the Center for High Throughput Computing, within which the HT Condor software suite and related tools are developed for use around the world and even beyond academia. So by bringing these two together, we've got this really cohesive set of services that for campuses mean that you can advance what you're doing to support distributed high throughput computing and researchers who have problems and projects that can be accelerated by high throughput computing. So first though, in case you're wondering, what is high throughput computing? I'll provide an analogy that when you've got a large computational problem, and let's say there's an analogy of building the world's largest cake, with the cake, there are sort of two approaches. One, you could try to build a really large oven, like a supercomputer, or two, you could build regular size cakes in regular ovens, even eliciting contributions of oven capacity that come from heterogeneous and diverse sources, maybe community contributed. This is exactly what was done for the Las Vegas Centennial for the world's largest cake. They basically sent ingredients and recipes to a large number of citizens who had regular ovens and contributed those in order to tackle the task of building the world's largest cake. And there are a lot of research problems that break down this way into large numbers of independent or mostly independent tasks that just need to be brought together or results brought together at some point. And there are a large range, like I mentioned, of research problems that fit this, and they tend to fit in a number of categories. These are just examples. There's certainly more beyond this. But text analysis, which includes most genomics, is a really good example where individual pages of text, individual genetic samples, or even genetic reads are often analyzed independently by the software that researchers commonly use, and therefore could be executed as lots of independent tasks. We see a number of things in the realm of statistical model optimization, other forms of what are effectively parameter sweeps, lots of independent computations with different starting conditions. And that's also similar to what we see for what's described here as multi-start simulations, whereby perhaps there's a weather simulation or some other physics-based simulation that needs to be run numerous numbers of times, but with different starting parameters, conditions, or even different molecular systems if it's molecular simulations. And then one that tends to also be really obvious to our researchers is if they've got multiple images or other types of samples that get independently analyzed and then results sort of brought together at a later stage. This can apply to not just images, but videos, where maybe different frames of what is thought of as a movie can be analyzed independently. And there are reasons why the Open Science Grid is a really excellent place to run this type of work. But on the computing system side, if computational work can be communicated and executed as many independent tasks, the computing systems and the requirements for running that work change in a way that allows for really extreme levels of effectively parallelism. And versus internal parallelism, right? A single execution with multi-threading or MPI, with high throughput computing, if each task only needs one or very few CPU cores, you can schedule more of these faster on a defined set of computing capacity and reach a peak sooner. There's no special programming required. A lot of users who come to the Open Science Grid or to high throughput computing may have been working on their laptop with a single core, but just looping over something. In this case, they don't have to go programming multi-threading or use parallel toolboxes. They can run something that ran on their laptop, but just communicate it as multiple executions that each start with different inputs. There's easier recovery from failure, both from the user's perspective and from the system's perspective. Basically, if one job fails, as long as the system can requeue that job and go run it somewhere else, all the other tasks, all the other cores can continue running to serve this particular user's problem and many other users in the same system. The number of concurrently running jobs is much more important to overall throughput and completion of the computational task. And things like CPU speed and homogeneity are much less important. It doesn't matter if one execution or one job is faster than others, because things are running independently, and what matters is being able to run as many tasks on as many computing resources as possible. So for this type of work, the Open Science Grid is really a wonderful and extremely scalable environment where researchers can run lots of high throughput computing work. And the Open Science Grid really is a consortium of research communities and the institutions who support them that share computing and data capacity in this distributed high throughput computing network to support open science. So effectively, via access points, researchers can run computing tasks on a large number of sources of capacity, and the Open Science Grid produces technologies and software that help make this a relatively seamless or sort of single virtual environment that brings together heterogeneous sources of raw capacity into effective capacity that is much more user-friendly. So who participates? Researchers and individual researchers and even small research groups, like many of what you probably encounter on your own campuses. Multi-institutional collaborations have been a significant portion of the Open Science Grid's history. Some larger physics collaborations like ATLAS and CMS that discovered the Higgs boson operate their own pools within the Open Science Grid, and I'll talk about pools in just a second. Science gateways can make use of Open Science Grid. And then certainly the academic institutions and national laboratories that support all of the above are incredibly important to making this consortium and the partnership of the Open Science Grid work. And the grid is really a set of multiple virtual clusters or pools, each of which is specific to a research community that has made some investment into using the Open Science Grid's technologies and software to organize heterogeneous sources of computing. So you may have heard these referred to in the past as virtual organizations or VOs, but as you can see, the CMS and ATLAS research communities have multiple institutions and computational staff who actually operate their own virtual pools, running OSG software to do so. There's also the Open Science Pool, which is operated centrally by OSG, funded by the NSF. And it's available to single researchers and groups through the OSG Connect access points that we operate, that any researcher in the US can access OSG through. Some smaller multi-institutional collaborations also run in this pool because they don't have the resources or investment to operate their own pool. And then campuses can have their own access points that submit into this pool as well. And what OSG does in terms of technologies is that we create and distribute and support the use of software referred to here as the OSG meta scheduling service to match jobs submitted at access points to sources of capacity that can come from a variety of sources. So in the Open Science Pool, we operate this instance of software beyond just developing it and producing it for the community. Access points are really Condor points, SCEDs for job submission, and they can be configured to submit to an Open Science Pool, to a local cluster, to both at the same time. You can operate local clusters with Condor, but they don't have to be Condor clusters in order to be available to your access point. So it's sort of like a single place where a researcher can access multiple sources. And similarly, through HT Condor and the OSG meta scheduling service based on Condor, beyond usual suspects, campuses and collaborators who share resources through the Open Science Grid, users can access allocated computing capacity from national supercomputers, or even have Condor negotiate the use of cloud resources on their behalf, charging their account and only so much to run just their jobs. So there are dHTC services represented throughout this entire diagram, also in our list of services. So going back to that, that diagram sort of represents everything that we can offer to your campus, building local capacity even, and each of these can be pursued completely independent of one another. You do not have to engage in any one of these services to be able to take advantage of other services listed here. Just to break some of these down briefly before we go off into our office hours rooms. OSG Connect, I've already mentioned a couple times, is the access point operated by OSG staff, and it's available to researchers at any US academic, government, or nonprofit organization. We meet with every new user to OSG Connect, including campus staff like yourselves, who can go sign up even today and start to use OSG Connect. We have online documentation and examples like you would expect from any sort of computing provider, access to support for software and large data, though we don't provide sort of persistent data storage space or sort of backed up space. It's all meant for active work that's running on the Open Science Grid. In the last year, we've seen a growth in the number of active projects. We even got a boost from COVID-19. And these come from a variety of sources. So the OSG Connect access points all submit into the Open Science Pool, which really represents a large, diverse community, mostly users from OSG Connect, but including users from, like I mentioned, smaller collaborations and campuses. And you can see that we've got a good breadth of research domains represented in the Open Science Pool. So if you're considering contributing, you have some assurance that this really is a diverse community. And there are campuses, even smaller campuses, that show up in the top users in terms of researchers from those campuses who come to the Open Science Pool, often through OSG Connect. If you're interested in having your own access point, this is kind of like having another cluster on your campus where you operate the head node, or in our case, the OSG access point, and provide all the user support, but you don't have to administer the worker nodes because OSG's technologies do that for you. And effectively on this access point, which could be a server, a virtual server, it could be an existing head node that does dual purpose submission to a local cluster and into OSG, you would do the user facilitation, although our staff can back you up, obviously, for that. You determine which user authorization and authentication mechanisms you want to use. So you can have on that server local authorization with local campus user IDs. You'll do some Condor administration on the access point, again, with our help, especially for setting it up and in any sort of ongoing troubleshooting way. And you can administer and integrate institutional data storage, including setting up your access point with an origin for large data that can be distributed automatedly through OSG's existing caching mechanisms. And it's not required that you share resources into OSG for your researchers to benefit from using OSG Connect or having a local access point. Like I mentioned, all these services are independent of one another, although you can integrate them together. And the last service that I'll provide just some more detail on is that you can share resources into the Open Science Grid, whether to the Open Science Pool, which is what most campuses do, or perhaps additionally, or even specifically to some other research community that has its own pool in the Open Science Grid. In the Open Science Pool, there are more than 100 US campuses already federated. Owners decide which pools they share with. This is configurable on our end, and nearly all of them support the Open Science Pool. We operate, in order to execute this resource sharing, a compute entry point that communicates through your local existing cluster scheduler that can be just about any type of scheduler, even cloud frameworks, local cloud frameworks. And we'll work with you so that you get to specify the job submission details of the jobs that we submit to your cluster, including which partitions, job sizes, priority our job should be submitted through. And then the OSG software running in your cluster in jobs of your local cluster scheduler, say Slurm, will communicate back out to the meta scheduling service of the Open Science Pool and accept user jobs in, even maybe perhaps as subsets of resources within the job that's running on your cluster, perhaps on a whole node. We also provide data on the projects that you impact. So while you have the ability in your local scheduler to tweak how many resources are made available to which research communities you support, if any, beyond the Open Science Pool, you can go to Grok and see exactly what that usage breaks down into based upon the projects that used your campus's resources and which fields of science, which campuses those people come from. So that's all available in our accounting system. Resource sharing tends to be the most relevant service for CC Star awards, primarily because CC Star Category 4 or compute awards require that 20% of computing time for the resources provision with your award or purchase with your award are made available to the broader community. And the Open Science Grid and Path are specifically mentioned as a mechanism for achieving this and as an entity for helping you formulate your CC Star award, even if it's not a campus computing award. For proposals and awardees, we offer letters of collaboration and support, and in consulting for your proposal on a number of aspects, not just OSG integration, including and beyond resource sharing, but also how you formulate and communicate your science drivers, and if you want help informing any of the other sort of technologies that you're pursuing in order to support the science in your proposal. You can learn more about all of the dHTC and OSG services from a number of sources, but not too large. First, if you haven't already, I would highly encourage you to come to the OSG All Hands meeting. It's virtual and free. Registration's open now for the first week of March. And this is where the community of institutions, researchers, and everything in between involved in the open science grid come together. And there's some specific content planned for the first 2 days in terms of impact to researchers and impact to campuses. We also did a dHTC campus workshop in October. If you missed it, the materials, including videos of presentations, are available through the website listed here. And that did a little bit more of a deep dive into resource sharing, including technical and security implications. Past Condor weeks have included lots of information about organizations that have used Condor, research impacts, and tutorials on administering Condor systems. And we also make a number of appearances throughout the year at community conferences relevant to research computing, including RMAC and PERC. If you're looking for information on using dHTC and OSG's user documentation is a great place to start. The CHTC and PATH have YouTube videos introducing Condor job submission from the user perspective. And the Open Science Grid User School, with an application period coming up soon, is targeted both for researchers and research CI staff. It's sort of an in-depth introduction to high throughput computing from the user's perspective. And there are wonderful past materials available from the website for the Open Science Grid User School. Specific next steps coming away from this overview of services. First, if I didn't emphasize it enough, you and your researchers can use OSG now through OSG Connect. And if you like, we can do all of the user facilitation, but you're also welcome to join us and to start building facilitation capacity at your campus. We talked about this in a little more detail in yesterday's training, so feel free to check out those materials or to show up in the office hours room for this topic. If you'd like to discuss the right services for your campus's priorities, again, that address is support@opensciencegrid.org. And if you specifically want to talk about consulting and letters for CC Star proposals, we have a separate email address for that that goes just to OSG leadership rather than to our whole team of staff. At this point, I'll take some questions and then we'll talk about what we're doing next for the office hours